Hello dear students. In this class, we will try to understand the concept of torque from rotational mechanics. So as we know, torque is the analog of force in rotational mechanics. Just like force helps to move body linearly in translation motion, corresponding to that in rotational motion, we have torque, which helps a body to turn. So the turning effect of a force with respect to an axis of rotation can be defined as torque. Now, what is the expression for torque and what is the magnitude of the torque? So, torque is a vector and torque can be defined as R cross F. So, F is the force that is acting on this body or this arm that is helping this arm to rotate. Vector force is denoted by F. And what is R? R is the vector from the point from which torque is measured to the point where force is applied, or it is the vector connecting this axis of rotation to the point where the force is applied. So remember that torque is also a vector, so it has a direction. Now as we know, what is R cross F? Its magnitude is given by RF sine theta. And what will be theta? Theta is the angle between the vector R and vector F. So in this figure, the angle between vector R and vector F, it is this 90 degree. Similarly, whatever be the angle between R and F, that is measured as theta. So in this case, this is the force, this is R, and the angle between them can be measured by moving this R vector a little to the front side, and this is theta. Or just like that, this angle can also be measured as theta here from the axis of rotation. This angle can be measured as theta. So simply, theta is the angle between vector R and vector F. So if we look into that, force into R sine theta is the effective torque that is felt by a rotating body. If the magnitude of the force is fixed, then R sine theta determines the magnitude of the torque. So this value R sine theta is often called the lever arm or the moment arm in the case of torque. So suppose this is our axis of rotation and this is our body. So this is R vector R. So we are applying the force here. We are pushing this body to rotate. So I can translate that force to this part. So this is the force. I hope you know we can move one vector from one space to another without changing its direction and magnitude like this. So this force and this force represents the same magnitude and direction of force. So here this force, I translated it to here, or I can move it to here to define angle theta. And we know what will be R sine theta. What is the angle between R and F here? So in this case, this is the angle theta. And this is the perpendicular distance from the axis of rotation up to the point where the force is acting. So this is the line through which the force is acting. And from the axis of rotation, measure the perpendicular distance towards the line through which the force is acting. And that perpendicular distance is R sine theta, which is also called the lever arm or the moment arm of this rotational motion of this case when torque is applied. So simply put, the lever arm is the perpendicular distance from the axis of rotation to the line through which the force is acting, the line of action of force. Now, what is the direction of torque? Torque is a vector, and we can find its direction by using the right hand grip rule. So if force is applied this way and this is vector R, the body will be rotating like this. So hold your arm in such a way that your fingers traces the path of this rotating body. Then the thumb will give you the direction of the torque. You can also find it simply by, you already know, if you have two vectors, its vector product will have a specific direction. It is given by the right hand screw rule. So the same rule can be also used to find the direction of torque. So here you can see the torque has the same direction as the angular velocity, angular acceleration. They all lies in the same direction. So that is very similar to the case of translational motion. There too, force, acceleration and velocity, its direction are same, its directions are parallel. Just like that, here torque, angular velocity, angular acceleration all have parallel or similar direction. Now, having understood about the basic concept of torque, let us think what is the unit and the dimension of torque. So since torque is equal to R cross F or R of sine theta, its direction is meter multiplied by Newton or Newton meter. So as a homework, find the dimension of torque. Now coming to some special cases of torque. Since tau is a vector product R cross F, tau has some very interesting values for certain specific angles. For example, consider the case when R is equal to 0. That means you are applying the force at the axis itself. This is just like you are trying to turn the door by pushing at the axis, at the hinges. Will you be able to rotate the door by pushing at the hinges? No, right? Or it is very difficult to open a window by pushing at the hinges. If R is absolutely equal to 0, torque is exactly 0. That means you will not be able to rotate a body by applying force at the axis of rotation. And the second case is that if theta is equal to 90 degree, then torque is equal to R cross F, which is R of sine theta. Here theta is 90 degree, so simply it is RF. So this is the maximum value that a torque can achieve. So in this picture you can see, here we are applying the torque, the force here to open the door. This point is at the maximum distance from the axis of rotation, so R is maximum. And if you apply that force at 90 degrees to this plane of door or to this vector R, you will have maximum torque. So that is the easiest way to open a door or rotate a body. Apply force at 90 degrees and at maximum possible R value. And the third case is when theta is equal to 0 degree or when theta is equal to 180 degree. In that case, torque is equal to R of sine theta. And what is sine 0 or sine 180? It is 0. So this case is equivalent to you trying to apply a force simply along this R vector line. You are pushing this door like this or pulling this door like this, and it won't open the door, right? It won't rotate the body. So whenever you apply a force along the direction of this vector R, so if you are pulling this body like this, it won't rotate. Or you are pushing this body along this axis, it won't rotate. So if you are applying force along this R vector direction, that will not have a turning effect. Force will be used, but it will not turn out to be torque. So that is why there are cases when another example is the gravitational force of sun or earth. They does not actually constitute any torque because the angle is there 0 degree or 180 degree. So this is the basic concept of torque. I hope it is clear for you. Learn about the basic equations and other basic concepts mentioned here, its dimension, its vector notation, its direction, the lever arm concept, and also learn about the special cases of torque. I hope this portion is clear for you. Thank you.